These are examples for section 11.3, area of circles and sectors. Example 1. What is the exact and approximate area of the circular region on the wrestling mat pictured below? Now this circle looks like what we would call an oval. It's an ellipse, looks like an ellipse, but it's really not because we're not looking at the circle from straight above. But it is a circle, and you'll see the two wrestlers are on the mat. Well, the circle's diameter is 32. So if we're going to find the area of this circle, area of the circle is pi r squared. And we need to find r. Well, r, of course, is the diameter divided by 2. And the diameter here is 32 feet. So we divide that by 2, and so the radius is 16 feet. Come back over here. Substitute it in. A equal area pi times the radius, which is 16 feet. All of that gets squared. Now when we square, we have pi. When we square 16, we square the 16 and we square feet also. That gives us 16 squared is 256 pi feet squared. This is the exact area. The approximate area, then, taking your calculator, putting in 256 times pi, second function pi, we get approximately 804.2 square feet. So there's a little over 804 square feet that will fit into this circular mat. Example 2. What is the area of sector GPH? Leave your answer in terms of pi. In other words, find the exact area. So sector GPH, remember a sector of a circle is sort of like a piece of the pie, piece of it. So this area, we want to find the area of this right here. And if you'll recall from your notes, the area of any sector, in this case sector GPH, is equal to a ratio of the entire circle's area. So the entire area, of course, is pi r squared, and we multiply it with a ratio out of 360 degrees, much like we did when we did circumference and arc lengths. So this would be the measure of arc GH over 360 times pi r squared. So we come over here and we define our variables. R for radius, it's 15 centimeters. And then we have the measure of arc GH is 72 degrees. This is the measure of the arc, not the length. And remember, for later on, that the measure of this arc is also the same as the measure of this central angle. They're exactly the same. 72 degrees. So we have what we need. Now we come back over here, substitute into our formula for area. The measure of GH, arc GH, is 72 degrees over 360 degrees times pi times the radius, which is 15 squared. First of all, the ratio does reduce. It reduces by 72. 72 goes into 72 once. 72 goes into 360 5 times. So we get 1/5 times pi times, now here's something you got to be real careful with. You cannot cancel 5 with 15 here. If we were to write 15 squared, we have to square the 15 before we can use the 5 to cancel it out, or whatever number we get. So this is 1/5 times pi times 15 squared is 225. Now notice that 5 and 225 are both divisible by 5. 5 goes into 5 once. 5 goes into 225 45 times. So now we have 1 times pi times 45, or 45 pi over 1, or simply 45 pi. This is the area of sector GPH, the exact area. We left our answer in terms of pi. We need our centimeters squared. So this is exactly 45 pi centimeters squared, this area right here. Example 3. What is the area of the shaded segment shown at the right, or the circle segment? Round your answer to the nearest tenth. Okay, recall from the notes that a circle segment is the section of the circle in between an arc and a chord. So this shaded area right here would be called the circle segment, or the segment of a circle. And it's got a corresponding triangle. If you go to the center, it's got a corresponding triangle that goes to the endpoints of that chord. So you have this sector, you have this triangle, and then of course you have the circle segment, which makes up the rest of it, of the sector. So we discussed that the area of a circle segment ST in this case, is equal to the area of the sector, and sector SRT, it's right here, minus the area of its corresponding triangle SRT, which is this triangle right here. And so once we subtract out this area of the triangle from this entire sector, we get what's left, which is the segment, the shaded region. So we need, let's go ahead and figure out what the formula is using all the sector and the triangle. The area of a sector, again, the formula is the measure of the arc, which is ST, over 360 degrees, times the area of the entire circle, pi r squared, minus the area of the triangle. And the area of a triangle is 1/2 base times height. So let's define our variables now. For the circle, in all its parts, we have the radius, which is 6. Then we also need the measure of arc ST. The measure of arc ST, there's no degree right here, but the central angle that corresponds to it is 135 degrees. Therefore, the measure of the arc is 135 degrees. So the measure of arc ST is 135 degrees. Okay, we have everything we need here. Now let's find B and H for the triangle. For the triangle, the base and the height. Remember, base and height are always perpendicular to each other. The triangle here is an obtuse triangle, so the base is 6 centimeters, which is the same as the radius in this particular case. So the base is 6, and the height has to be perpendicular, so it's got to be a part of this extension up to the other third point of the triangle right here. So this is the height, 5.2, or 5.2 centimeters. So now that we have our dimensions, we come back over here and we substitute in all the values. So the measure of arc ST was 135 degrees over 360 degrees times pi times the radius, which is 6 squared, minus 1/2 times the base of the triangle, 6, times the height of the triangle, 5.2. At this point, be very careful that you use the order of operations as you work through this. 135 over 360 will reduce. It reduces by 45. 45 goes into 135 3 times. 45 goes into 360 8 times. So we get 3 to 8. Times 6 squared is 36. So we have pi times 36, or 36 pi, minus 2 in the 1/2 we'll divide out with 6, these two factors. 2 goes into 2 once, 2 goes into 6 3 times. So we have 1 times 3, or 3 times 5.2. Next, notice that 8 and 36 are both divisible by 4. 4 goes into 8 twice, and 4 goes into 36 9 times. So we get 3 times 9 pi over 2. That's 27 pi over 2 minus 3 times 5.2 is 15.6. Now I'm going to pull the pi out. You don't have to, but I'm going to pull it out. So we have 27 halves pi minus 15.6. Now we cannot combine these because this is a pi term and this is not. And so this would be our exact area of this circle segment, and it is in centimeters squared or square centimeters. They want us to round to the nearest tenth, so this is our final answer. Be careful in your calculator. This is 27 divided by 2, enter, times pi, enter, minus 15.6. And you should be getting 26.8 centimeters, rounding to the nearest tenth. So the area of this sector right here in square centimeters is a little over 27.5 or 27.8 square centimeters.